Hello everyone, welcome to my channel. And recently I've started working on a small project on machine learning, which is on the Titanic datasets, right? So I'm recording the video and the overview of the project that I've worked on so that others can also utilize from this and for my own personal purpose as well. Okay, so what are the objectives for this project, right? The objective of this project is to perform um, a step-by-step data analysis to understand the key factors that influence survival of on the Titanic, right? And we will we will be performing um, many things like covering the data, cleaning the data, analysis of the data, feature engineering, and the visualization with proper examples. Okay. So the what is important in this, right? The major important things that we have to do is are mostly four steps, right? Understand the data that is given to you, right? We have to understand the data that has been given to you, how they are related to each other. Data cleaning is the next step. So we have to clean the data. Let's say the data might have null values, empty values, unuseful data, and all. So we have to clean those data. Then we have to do feature selections, right? What does feature selection will help us in improving the logic of our problem and finding relevant data sets which will contribute in a better uh, data set for the machine learning models, right? And then assumption checking, it allows you to check assumptions that are required for certain machine learning models. Okay, cool. Cool, I'll just show you the data sets first. That the first, if you see their data sets, there are around 800 something datas in this, and you have passenger ID, survival ID, Pclass, passenger class, what is the class of the passenger, name of the passenger, sex, age, right? And you can see here it is null also. Sibling relationships is there, parent relationships is there, ticket is there, ticket number I think, and the fare of the uh, ticket, right? And the cabin, if the passenger has a cabin or not, right? And then there's embarked column. Okay, so the first thing that we'll do is we'll import all the necessary library that are required for the uh, this project, right? We need pandas, NumPy, and Matplot for plottings and all, and SNS for drawing these graphs, right? Okay. Okay. So what we have done here is just a simple thing. We have set the theme and then imported the libraries. So after the first step, the importing of the libraries is done. Then the next step is the data loading and initial inspection step, right? So we'll load the data. So we have this data sets on our folder in our directory and with the name of Titanic data sets. So we'll read this data and we'll so df.head displays the first 5 rows of the data sets, right? So you can see the first 5 datas that are present here, right? And there are few columns which are present here, right? And df.tail will present the last five entries of the data, right? And df.shape, it will tell you the number of rows and columns that are present in this particular data sets, which is the Titanic data sets, right? And if you do df.info, it will give you a overall summary of the data set that you have. So if you see, there are around 891 entries, 0 to 890, and there are around 12 columns. If you count this also, 1 2 3 4 5 6 7 8 9 11 12, there are 12 columns, right? Each column has a not null count and the data type that is shown by the df.info, right? If you see the passenger ID, they are around 891 not null values, and the same survivor ID, passenger ID 6. So the column age has few null values. Uh, like it has 714 null values, and few of them are not null, or few of them are null. And same thing goes for cabin and embarked, right? So if you can see, there are three columns with the which have null values, right? So set at every step we are trying to identify. So in the data cleaning step, we have to clean up the data which are null and not necessary and all, right? So if you see what are the interpretations of this data, you can say what is the summary of this data. So it's better you summarize the data for your own purpose and understand what the data is trying to convey to you, right? So at this step, we can see that there are 88 legible entries and 12 columns. Correct. These are the columns. Missing values are identified. What are the missing values identified? Because we have to clean those data now, right? So which is age, cabin, remarked. And if you see, age is 714, and cabin remark embarked is 889. So now these two values are a lot. Few of them are null. And if you see the cabin one, right? Uh, Majority around 77% of the data are missing, right? Or there's, you can say they are null. So we have to uh, work on cabin in a different kind of way, right? Okay, cool. Uh, no, what we have to also understand is the numerical, um, sorry, huh, understand numerical features of this data, right? So whatever the data sets we have to understand the numerical features of the data. So if you do df.describe, it gives you a couple of mathematical values. One is the count, one is the mean, standard deviation mean, 25, 50, 70 max percentage, right? So we'll cover few of them, and which are important, right? For database analysis, data analysis. Okay, so if we see here, in this particular data, the survived about the mean of this survived is around 38% of the data sets have survived. So 30% of the um, passengers which were there have survived. Okay, and then we can also see the range of the age, right? So there's a minimum age of 4.42, which is 5 months, and the maximum age of around 80. So, and with an average age of 29.69. So we can see these are the three relevant data that is there. So we have kind of noted it down also for our reference, right? And the fair, we might also have to talk about fair, right? And you can talk about other data also, but we'll talk about few of the data sets which are important in this, and based on the requirements, you can talk about those data and generate those data and work on those data sets, right? So if we talk about the fair, we have to see the mean. Okay, the mean is around 32, uh, and yes, $32, and but a median of only $14. So, but a median is of only $14. The maximum fare is of $512, indicating the presence of extreme outlierness. So there is a presence of extreme outlierness which has kind of deviated the data from this, from the mean or median. Yeah. So the next step is data cleaning, right? So, uh, what all things we have to clean, right? Before analyzing, the most important thing is the you must handle missing values that we have identified, right? Uh, which is also known as imputations, right? Imputation is what is imputation is the process of replacing missing data with substituted values, right? Uh, and this substitution can differ for different data types and for different data types. So if it is in numerical data, we kind of use a skewed distribution using the median of the values, and for the categorical data, we use a common strategy and use the mode, which is the most frequent value used, right? And for high cardinality or too many missing values, which was in this case cabin, like if we have seen above, or you can see in below also, it's 687 null values. uh, the imputing might not be effective, right? So if you impute it with the median or mode, it might not be giving you the exact data. So the better way is to derive a new feature from it, and maybe work on that, right? So in this case, we can the Kevin data sets that is given to us, right? So if you see what is the data that is given to us is is the Kevin numbers and all. So these might not be informative enough for us. So we can kind of draw new features from it, and work on that, right? So if you so the first step is the missing values before cleanup. What are the missing values? If you can see, df dot is na dot sum, so it sum ups the all the missing values. So age has 177, Kevin has 687, and Embarked has 2, right? So we'll go one by one. So we talk about age first, right, which is numerical data, and numerical data can be replaced with the median. So I think I'm just checking the median value here, and categorical data is the embarked one. So we are just checking the values here, which I got 28 and S for it. Now median, and then I simply replace the median in the data frame with the median age that I've got, right? So that I've done and then just printed it. And then for same for the embarked, right? For the embarked one, I have to replace with the embarked value, new embarked value, which was df.embarked.mode. 0 I have written because I have to get the value of it, which is s here, right? And then what I'll do is I'll again kind of print these three columns and see if the data is cleaned or not, right? So if you see, the age and embarked has been cleaned. So what we have done is we replace the empty values with 28 for the age, and for the embarked we have replaced with S, the missing values, right? One was the numerical data, and the other was the categorical data, right? And coming to the third kind of data, which is high cardinality or too many missing values, which is in the case of Kevin, right? Uh, so, uh, so as we discussed above also, it's better that we kind of generate a new feature out of it and then work on that, right? So what we have done is we have decided to build a new feature called has cabin, right? So what does it will tell you, right? It will tell you if the particular entity or this particular ticket is a or a particular seat is a cabin or not, right? So so what we have done is one is has cabin and zero if not, right? So we have done a kind of a binary encoding here, right? So what we'll do is we'll simply so this is to show what will happen. So 0 and 1 will be it will be replaced by zeros and 1, the given data sets, right, that we have here. So we have done the same thing here, like we have replaced or kind of modified the value and created a new column called has cabin, and we have assigned a binary encoding to it, which is zeros and 1. And what we have also done is we have also dropped the original column called cabin because it is of no use for us, right? And maybe some other feature which is required, maybe we can include that, right? Okay. Now we have done values count. Since it's a binary encoding, so it's telling us for each value how many is the count. So for zeros it is 687, and for one it is 204. Right. Again, then what we are trying to do is we're trying to print this 5 elements. And now if you see the data set that we have, passenger ID, survive, Pclass, name, sex, age, SIPS, ticket, and like the last column is the has cabin, right? I hope you guys are understanding, and this is the code part of it, and then this is the execution part of it, right? So maybe uh, what I'll try to do is mm, what to restart. Okay, you get the idea, right? Run this particular code block. Let me do it. Uh, so yeah, so if you have to run this particular code block, see the data sets, right? So I've already run it, so you guys are able to see that, right? So if you see here, correct? I'll run this, I'll run this, data cleaning step, and then this, got this, then this block. I'll run it as many as this, and then this, and then we have replaced this, we have replaced the embarked one, and then we have added a new column call or a new feature called has given, right? Has given, and then that we can visualize in this particular data sets also, right? And then what we have done is we have again, after cleaning all the data sets, we just want to verify again if the if everything is done or not, right? So if you can see, there is no missing values as such, right? So if you see, we have two things, two steps till now, have done till now. So first is the importing and the data loading and the inspection of it, and then the third step is the data cleaning phase, right? And then we have also done that, and then the next step is the okay, it's three. And the next step is the univariate analysis. I think this is the step four. Okay, so the next step is the step four, which is called univariate analysis. So what we do is we look at each variables, like these are the variables that are there, and individually and understand its distribution, right? So the target is to understand the distribution of each of the variables that are there in the data sets, right? Why it is called univariate? Because we will do analysis on one of the variables at a time, and then for, if you have to do bivariate analysis, you consider two variables and do the analysis, and for multivariate, we consider multiple variables and do the analysis on that, right? Right, and now univariate analysis, right? So this is the simplest form of data analysis that we do, where the data being analyzed contains only one variable, as we discussed above, right? The main purpose is to describe the data and find patterns within it, right? So the main purpose is to understand the data that we have, right? The individual variables that we have and find the patterns around it, right? Now there are two kinds of variables, if you have noticed, right? One is the categorical variables, and the other one is the numerical variables, right? Uh, Categorical variables are these ones, right? Embarked is one of the categorical vehicles. Uh, Pclass is one of the categorical vehicles. Survived is one of the categories, right? So you have categories right here: zero, one, one, two, three, right? Sex, male and female, right? These are categories that are there, right? And obviously the numerical variables are what? The numerical variables, the age, the fare, and the ticket I'll not consider, and then maybe the siblings and SIB and all, right? So, no, not SIB, but yeah, age and fare you can consider as the numerical variables as of now. So what we do is for categorical variables, we use frequency tables, bar charts, or pie charts to see the count uh, of each category, right? So, and then for numerical variables, we draw histograms and density plots to understand the distributions, right? So what we have done is we have used SNS, which is which is the Seaborn, to do the plotting and all, right? So what we have done is we have decided a plot of 2 cross 3, which means there are 2 rows and 3 columns and 6 plots. We are plotting at the same time, right? All these things, other things you can obviously Google and understand. These are not important as of now. And then I'll just cover the important parts. So coming back to the what is 0, 0, right? Okay, one second. So if you see 0, 0 means this plot, 0, 1 means this plot, 0, 2 means this plot, 1, 0 means this, and 1, 1, 2, right? I hope it's clear. So the first thing that we want to work on the categorical features, which is survived, right? which was zeros and one, and then it's the P class that they want to work on, which is the P class, and then the gender that we've talked about, which is the sex, and then the embarked SQP, I think SCQ, and then SIB, sibling spouse about relationship, and the parent-child relationships, right? So we have kind of plotted all these data sets and draw a count plot to understand the data sets, right? So what does it see? So 0 means not survived and 1 means survived. So around more than 500% of the people have not survived. And coming back to this, more than uh, the third P class peoples are more in this uh, Titanic data sets, and the gender male is dominating in this particular data sets. And yeah, so if you see, I've written down the key insights for all of them. So more than around 400 people did not survive. Third class is more important than the first one. Most populated, sorry, sex was male was more. Embarked me, if you see the S, Embarked was the majority of the people were from Southampton, and then the vast majority of patients were from Southampton, and for the sibling spouse or parent child relationship, most passengers have traveled alone. So if you see, this is zero, right? So zero means no siblings or spouse, and parents means no. Zero means no parents and children, right? So the frequency is around 600 for all these. So means most of the frequent or the traveler or the passenger in this particular data sets are traveling alone, right? Cool. So I think we have done one analysis, which is the categorical variable analysis, and then the next one is the numerical variable analysis, which we do via histogram or density plot or box plots, right? Cool. So if you see the data sets which are relevant and important and are numerical are of type numerical as the age and the fear that we can consider. Um, and coming to that, so what we'll do is we'll draw the histograms for these, right? So what we have done is we have drawn a histogram for this, and again subplot means one row, two columns, right? So the first one will contribute to age, and the second one will contribute to the column. So what we have done is we have drawn the histogram for this, right? So yeah, yes. So what are the key insights from that we have gotten from this? The key insights that we have gotten from this data sets is that most what the distribution tells that in the age of in the around 2030 range, right? The age distribution is high, and also we have kind of filled the missing values, right, with a median of 28. So that's why this part is of uh, has the highest peak here, right? Because most of the data were missing. And then if we talk about the fair, right? So if we see the distribution at zero, around zero, the distribution is high. And if we go on the right hand side, the distribution becomes less. And you can see one distribution here. So it tells that most of the flights were cheaper and few were very expensive, right? Which is around $500 and all something. Which we have also seen here. I'll just show you. So if you see here, if we talk about fare, the mean is 32, right? And the high max is 512, right? And the minimum is zero around. Okay, so we have done the categorical variable analysis, numerical variable analysis for univariate. And then maybe we can move on to the next step, which is the bivariant analysis, right? And what does bivariant means, right? As we discussed above, we will draw out a relationship between two variables. Uh, where obviously we can target one of the variables which is of our primary focus, and in this case we will obviously target the survive variables, right? Because we want to understand how many people have survived, and they belong to which sex or which P class, or do they even have the cabin or not, right? Okay, so there are multiple so theoretically wise we can do if there are two variables, right, and the relationship between these two can be categorical numerical, or numerical or categorical, right? Because we had only two types of data sets, and at least in this data data sets, right? One is categorical and numerical, right? So what we'll do is, obviously we'll try to understand the bivariant analysis between the survived and the pre-class and the sex and the embarked and the has cabin, which was a new feature with that we have developed, right? So for this bivariant analysis, we always use we kind of use a bar plot. So that we have done here is bar plot xs6, so 2 cross 2, so 4 parts we have to draw, and then 0 0 0 1 1 0 1 1, right? So 0 0 x-axis you can say is the P class, and the y-axis is the survived one, right? And we have passed the data frame that we have generated on top, right? And we have set a title for the P class. Similarly, we have done it for sex, we have done it for embarked, and we have done it for has cabin, right? And then these are only for the visual purpose and all, right? So if you do analysis from this data sets, we can see that um, the P class one, right, right, uh, had a 60% survival rate. Then the second and or the third class. So the third class has around 20 to 25% of the survival rate, right? Next thing is on the sex side. Most of the passengers uh, who survived, most of them were female. So that is what we have done, concluded from this data, or the bar graph we have drawn here, bar plot, right? Around 75% of the female, and embarked passenger embarking from sea had a higher survival rate than from others, and most of around 65% of the passengers have survived who had a cabin, right? Has a cabin, right? This is likely correlated because they were the first class people. So as you can see there, okay, those were the key insights, and then this was for the survival. This was for the categorical data sets. Category, this is also category. That is numerical. I think one category is numerical, right? So we want to understand the age versus survival, right? Uh, so what we have done is, we have drawn a facet grid on survived, and then we have drawn the age histograms, and then we have tried to plot it out. So if we have seen here, okay, so if you see there, they the data observation that we can conclude from here is that a large portion of non-survivors were young adults, right, around 20 to 40, those who have survived, right? And this is the median age, so that's why it has skewed on top, right? And the oldest passenger has not at all survived, if you can see it from here also, right? And yeah, ideally none of the passengers who are around 70 to 80 age have survived, right? Okay, cool. And the other one is, we have done age, and then we will do the analysis on the fare. So for fare, I think we have drawn a box plot uh, to figure out the data, right? So the box plot confirm that if you draw this box plot, it confirms that the presence of significant outliers. What are the outliers which has skewed this data? So most fares are concentrated below zero, uh, below, sorry, below $100, but there are several fares ended far beyond, right? So there were fears which were around $500 also. Some and of 100, 200 and all, right? They are most likely the first class passenger who has booked luxurious shoots and all. For some machine learning models, handling these outliers through log transformation would be an important step. So one of the important steps for us to be handling these outliers that are there, right? Because because of these outliers, the data kind of get um, not significant, right? Okay, cool. So we have covered multiple things till now. Analysis. The last thing that we do is the analysis, right? The next step is the feature engineering, and after that we have correlation analysis, and then I think white profiling. Okay, cool. Okay, coming back to feature analysis, feature engineering, right? So the the exact job is to create new feature from the existing ones, right? To potentially uncover helpful insights and provide useful information to the models, right? Machine learning models that are there. So if we are able to generate new insights or new feature from the existing features, so obviously that might help the machine learning models to understand in a better way. Cool. So feature engineering is the process of using domain knowledge. Obviously, you have to get the domain knowledge of this data sets or the field and to extract the features, characteristics, properties, and attributes from the raw data. So from these raw data, if you have the domain knowledge, you will be able to extract new properties, attributes, and all, right? And then um, create new features or relevant data to solve the problem and in a much better way, right? So common techniques that are there to do the feature engineering are the combining of features, extracting from text, and binning, right? So for combining the features, there's example that you can do sibling plus parent equal to family size. You can draw out a family size feature, a new feature which will help the models to draw a better analysis, right? So if you see here, we have created a new data frame called family size with the siblings and batch, uh, and we have added one for themselves. So and then if we see the data frame, we can see that we have created a new column uh, which has two family size, one family size, right? And then also we have created a new column or a new feature called is alone. If the family size is one, obviously they are alone, right? Otherwise they are not alone. So 1 and 0 we are pointing out. Obviously this will help us in understanding the people who are traveling alone, right? And then help them in the worst case and all, right? Cool. So we have drawn out the new feature called family size and the new feature called is alone, and then analyze the new family related feature against survival, right? So we are what we are trying to do is against survival, which was one of our main variable on which we were doing the analysis in bivariate analysis. So we are now trying to do a bivariate analysis again against the survival with the family size and is alone, right? So most of the people who were alone have survived. If you see the analysis here, um, and the family passenger who were alone had survived, and who were not alone had around 30% survival rates, right? And small families 2 to 4 has the most highest survival rate. All others were had a highest lowest survival rate. So if you see family which were had a size of 6 had the lowest survival rate from this graph, right? Which is the bar plot. Okay. And then obviously, so we talked about the combining features and extracting and combining a new, creating a new feature, and then the extracting from the text, right? Pulling out specific information from a text, right? Extracting titles from name. So one of the example is that we extract the titles from the name and do the analysis and see, understand, and extract the titles from the name and do the analysis of what our titles were kind of um traveling or passengers were there, right? So what we have done is we have simply written a regex expressions to extract the titles, and then we have counted the counts for all of these titles. So we have found out around these many titles were there, and these were the count. 517 were misters, and 182 were misses, and right doctor was 7, and lady was 1, Don was 1. So if you see, few of these titles are very rare, right? You don't encounter on them on a day-to-day basis, right? So what we'll do is we will kind of group them into a smaller data set or the categories, which will help us in understanding the data properly or in a much better way. So we have that is what we have done here, and we have kind of distributed the data into five titles, which is Mr., Mrs., Miss, Master, and Rare. Rare includes these titles that we had, right? So if you see, Mr. has survival rate of around 80%, right? So Mr. has the most survival rate. So I think um, that is what we have seen above also somewhere. Um, where did we see? Okay, uh, check it. Okay. Okay, so sorry, Mrs. My bad. Mrs. has the most survival rate here. So if you go up here, yeah, so we can see that the female has the most survival rate also, right? And the male has the less survival rates. So that is what the conclusion we have drawn from the new bivariant analysis. Obviously, by doing a feature engineering for this, right? And then the feature engineering. One second. Bivariant analysis, feature engineering, and then there's also a step for multivariant analysis where you work on multiple variables, right? And multiple variables simultaneously, and 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 draw your perspective on top of it, right? So what we are trying to do is, in this we are trying to do a P-class versus survival probability, where the graph shows blue one shows for female and orange one shows for male, right? So if you see for class 1, the probability is around almost 1%, and this is around something less than that. And then same thing for, so in each of the um class, the female percentage is higher, right? So in each of the class, the female has only survived more than the male, right? And then we have also drawn a violin plot for the age distribution by sex and survival. So this is the male, and this is the female, and this is the age, and the blue one peaks shows, or the blue part is for the survive and the orange part is for the non-survive. So for males, the peak of the distribution for the survivals orange is at very young age. So if you see here, right, uh, the survive one, and while the peak for non-survive is around 20 to 30. So if you see non-survivor passengers that were there were around 20 to 30 age, right? And for the female, if you see, the distribution of survivors is much broader. So it's broader, right? So kind of there's no sudden peak in like this for which were in male for the female, right? uh, Indicating the female of most age had a good chance of surviving. Okay, so if you see this part also, so they had a good chance of surviving, right? and kind of all age distribution has kind of same um that's okay. So the next step, or the one of the last steps, is the correlation analysis, right? So basically it helps you in understanding the correlation between each of the features that it has, right? So if you see survived, right, survive has a positive correlation, so with fair and cabin, right? And if you see, there's a negative correlation between the p class, which is 0.34, right, and is alone also. And for p class and fair, if you see, p class has a strongly negatively correlated, right? And this p class and fair strong, which makes sense because the first class had a higher fare, right? The class. And same thing for the has given also, because the has given um, were there for the has given uh, were for the p class with first class, and which also had a high fare, right? And if we talk about the family size, right, so is composed of SIB and patch, like sibling and patch. So these are the two most contributing factor and highly correlated by definition, right? So this kind of show a correlation analysis of the data that we have between the numerical features. Okay, or between the features. Okay, so the next step is the Y profiling. So like we have done the analysis, we have drawn few we have done few feature engineering, we have done the cleanup and everything and all, right? So the next thing is the Y profiling, right? So this is just an example. I was testing something out. So Y profiling automatically generate an in-depth analysis report, right? Summarize data type, missing values and distribution, show correlations and potential data quality issues, helps understand the structure and characteristics of a data sets at a glance, right? So what we it's quite a simple, right? We kind of import the profile report from Y data profile, and then we pass the data frame, and then we kind of uh, to notebook iframe we generate the HTML of it, right? And then we save it to a HTML file, correct? So key findings again, if you want to discuss, title and sex analysis were there. Mr. and Mrs. was the most significant. There, our engineering title captures nuance better, sex alone, and also showing young boys master had a much higher survival rate than the adult Mr. and Mrs. has the more, right? There was a clear survival history. First class passengers survived more than the others too, and child and infants had a higher survival rates, and the older people who were there, they had a almost null survival rate kind of thing, right? Other influential factors that we can draw is family size of 2 to 4 had a better survival rate than a family who were traveling alone and had a larger family, right? And same thing, if you see if the price of the cabin were higher, they had a more survival rate, right? And the people who were from Sherbong had a more uh, survival rate, possibly a higher promotion of them were in the first class. Okay, so I'll just show you the Y profile that has been generated by the um, Python library. So if you see this, it tells what number of variables that were there, observations, and few other data sets, and then it shows the alert, reproductions, and all. I think this is not clickable, but you can see it later. You can see the passenger IDs, obviously all were distinct IDs, so this shows distincts, right? Minimum was 1, maximum was 891, right? Survived, it has two distinct values, like zeros and ones, right? 542, 549 did not survive, 342 did survive, right? And there was three distinct classes, right? And there was name, most of them were unique, almost all of them were unique. There were two types of sex, male and female, and there was around 88 different ages, and most of them were around 30 or something, like 28 is the median. And sibling chain relationships, there were around 7 relation kind of different sibling relationships, 0 to 4 6, that you can see, and same for the parent and all, right? And there was around 60 different distance. So embarked, so every feature or the column has its own kind of data generated, right? So you can see different kind of data. Obviously these are clickable, and this is the correlation heat map that we had generated here, right? That is also being generated. And it is showing few of the samples data. So if you see, it has family size, is alone, title, that we generated here. Okay, cool. So I think this was a big video, and I hope it will be helpful for you to understand the Titanic data sets, and will also help you in implementing in your new projects. I'll be posting few more, couple of more videos time to time when I do the analysis, or I learn from anywhere else, right? And obviously it's for my learning purpose as well, and for other people's out there. So if you like the video, please like, share, and subscribe, and do comment if you have any feedbacks, or if you don't understand anything. I will love to cover that in next videos, or in a separate video or something, or I would love to reply. Thanks, and see you in next.